In this video, we will discuss the Teledyne Monitor Labs LightHawk 560 opacity monitor. We will cover the operation, standard components, and the most common maintenance event, cleaning, and the on-stack calibration. The LightHawk 560 is a double-pass system design. An LED light beam is projected through the sample path, and the optical head measures the attenuation of the amount of light returning from the reflector. The opacity is equal to 100% less the percent transmission, i.e., 80% transmission equals 20% opacity. The major components include the optical head, the retroreflector, the calibration kit or audit device. The optical head contains all the electronics necessary to focus and project the light beam across the sample path, receive the light reflected back into the detector, determine the light attenuation, and deliver an opacity reading. The head unit is also equipped with a numeric keypad for operator interface. A list of data codes can be found in Chapter 3 of your manual. Common user codes are U or user bank. These codes are used to check values like calibrations, status, and reading. S or service bank codes are used to make changes to values during the maintenance event. The calibration mechanism is attached to the head assembly, which we will discuss more later. The zero and upscale reflectors can be commanded by a request bit or an internal clock. A DC stepper motor controls and drives the positions of the zero and upscale reflectors very precisely. The retroreflector assembly is mounted directly to the opposite side of the stack and concentrates the light beam back to the head unit. There are no electronics in the reflector, but rather one pressure microsensor and a relay for the purge air status returned to the head assembly. Last, the calibration kit mounts in front of the exit window when performing maintenance or audits. Each calibration kit is unique to the monitor. It is adjusted during an off-stack calibration to simulate the sample path, or 0% opacity. 100% opacity, or the background, can be achieved by inserting a blocking plate into the filter slot. The filter slot is also used to house the NIST certified neutral density filters during a quarterly audit. So let's begin routine maintenance and perform a cleaning and on-stack calibration. First, let's review our tool and equipment checklist. We will need a standard screwdriver, 3/4 open-ended or adjustable wrench, calibration fixture, neutral density filters, cleaning solution of 50% DI water and 50% alcohol, lint-free cloth, canned air, and a blower filter. An on-stack calibration is generally performed quarterly or on an as-needed basis. This process is generally completed in 3 steps. 1. Checking purge system and changing the air filter. 2. Cleaning the optical lenses and aligning the optical head. And 3. Installing the cal kit fixture and performing the on-stack calibration set. First, change the blower filters. Then we can continue on to cleaning the optics. Open the optical head unit. Gently blow off the exit window and the cal fixture with air to remove any large dust particles that could scratch the glass during cleaning. Wipe the exit window and calibration mechanism optics with the 50/50 cleaning solution and a lint-free cloth. Blow off the glass once again to verify all moisture is evaporated. Install the cal fixture to the optical head assembly. Be sure the fixture sits flush against the face of the optical head. Gently tighten the screw to ensure the fixture stays in place. Create 100% opacity by inserting the blocking plate. Then initiate the background set by holding Set and Background until the set light flashes 5 times and goes solid. The background set will take about 6 minutes. Once the set light goes out, remove the blocking plate. With the blocking plate removed, you can now initiate the normal set. Do this by holding set and normal buttons for about 6 seconds or until the set light goes solid. The normal set can also take up to 6 minutes to complete. Do not disturb the unit during this process, as the ClearPath current reference values are being re-established. Once the normal set is complete and the set light is out, you can now perform the zero set. For this last set, you should remove the cal fixture. Initiate the zero set by holding set and zero until the set light is continuously illuminated. Once the zero set is complete, the unit requires 2 calibrations to calculate dirt. This would normally be done with the unit returned to normal, but we are leaving the unit open to show the cal mechanism. Initiate the cal by pressing upscale and zero buttons together, then letting go. Watch for the in cal button to illuminate. The cal takes approximately 4 minutes. Notice the calibration mechanism lowers to check the zero, rises to check the span, and then returns to normal position once the check is complete. After 2 calibration cycles have been performed, the set procedure is complete. Check that the zero in the user bank 6 or U6 is the same as the dust compensation U8. If they are not, perform the on-stack set procedure again. After the 2 cal cycles are complete, note the calibration value in U7 and set the value in C1 and in the DAS to match.